I'm Anil Kumar, and in this video I'll teach you a technique to read the limits of rational function as x approaches positive or negative infinitely large value. So the question which we are looking into is, how can we read the limits of rational functions as x approaches positive or negative infinity, right? So we'll take a few rational functions and then work it out. As such, what is a rational function? Let me write that first. So rational function is quotient of two polynomials. Say r of x is equals to a polynomial divided by another polynomial, and of course the denominator q of x is not equal to 0. That leads to restrictions. Now whenever we have rational functions, then there's a polynomial over the other polynomial. Now we'll take three cases. Case 1, when degree of polynomial p of x is less than the degree of the polynomial q of x. That's the first condition which we'll take. The second condition which we are going to take is that their degrees are equal. Degree of numerator, that is equal to degree of denominator q of x, and the third condition will be that degree of the numerator is greater than degree of denominator. Is it okay? So we'll take three cases. Well, these could only be three cases, correct? And we'll also see how to find limits. So degree of numerator is less. Let me take example. We'll find limit. X approaches positive infinity. It could be positive or negative, so we can test both. And let me write the function. We want degree of denominator higher, so let me write this as x cubed plus 2x minus 1, and lower for this, so we have x squared minus x plus 2. Okay, so let's take this as a function. Since the degree of numerator is 2 and that of the denominator is 3, degree of denominator is higher. In all these cases, our answer should be, it says how can we read the limits of this? Our answer should be 0, right? So this limit has to be 0. Let me show you how. So the strategy is like this. Write down limit. X approaches infinity. We could take x squared common from the numerator, and so we get 1 minus x, 1 over x, divide this by x squared plus 2 over x. Is that okay? So we've taken x squared common. In the denominator, we'll take x cubed common. So we get 1 plus 2 over x squared minus 1 over x cubed. Now, if x is very large, in that case, these numbers are 0, right? These numbers are 0. Now here, what we have is x squared over x cubed. So let me write this first as limit x approaches infinity, and x squared and x cubed, we get 1 over x, right? And as far as this thing is concerned, we have 1 minus 1 over x becomes very small. Let me rewrite this. I'll do it in the next step. Okay, that's fine. So I'm just writing this 1 over 2x squared, 1 over x cubed. Now if x is very large, in that case you can see these are 0, right? So these values will, 1 over x will approach 0, this will approach 0, this will approach 0, this will approach 0, 1 over x squared, right? So we are left with 1 over 1 or 1 over x. So this gives me 1 over x. If x is very large, we are dividing by a large number, 1 over infinity. So this approaches 0. Do you see that? Now it works well with negative value also. So even if you try for negative infinity, 1 divided by a large negative number will approach 0. You get an idea, right? Now let's take another example here. That is when their degrees are same. So we'll write limit. X approaches, this time let's take negative infinity. So their degrees are same. Let's say we have x squared plus 2x minus 1 divided by, let me write this as 2 and this is 3. X squared plus 5. So So we'll do this as limit x approaches negative infinity. We'll take x square common, okay? So we'll take, or we can take 2x square common. That's fine. We can take 2x square common. So what we have here is within brackets 2x divided by 2x square will give us 1 over x minus 1 over 2x square. And the denominator will be, let's take 3x square common. 3x square common. So we get 1 plus 5 over 3x square. Is it okay? Now if x approaches a large value, in that case what happens? These terms approaches 0, right? They cancel out. So we have now limit x approaches negative infinity. X square cancel out. So we have 2 over 3. Do you see that? And within brackets, what do we have? We have 1 plus 0 minus 0. And in this case, we have 1 plus 0. And that is 2 over 3, right? So limit for a constant is a constant. So we get ratio of the leading coefficient. So this answer here, when the degrees are same, is 2 over 3. Do you see that? So that is how we get this answer. Now the last example here, we'll take limit s approaches infinity and the degree of numerator is higher. Let's say 2x cubed plus 3x minus 1 divided by, let us say x, right? Or let's say x squared plus 1. Okay, so we'll adopt the same strategy. We have limit x approaches infinity, take x cubed, let's take 2x cubed common, or x cubed, doesn't really matter, x cubed, and we have 2 plus 3 over x squared minus 1 over x cubed in the numerator, and the denominator we can take x squared common, so we get 1 plus 1 over x squared. Now as x approaches infinity, all these terms approach 0 wherever x is in denominator. So these terms approach 0. Is it okay? So what we have here is limit x approaches infinity. We get 2x. Now here x cubed and x squared. So we could write this as 2x, right? Because x cubed divided by x squared is x. 2 divided by 1 is 2. Now you can see this approaches infinity, right? Or we can say it does not exist. So that is what happens when the degree of numerator is higher. Is it okay? It approaches infinity. Correct? So that is kind of a rule. So let us have a few practice questions. Let's say, what is the limit when x approaches minus infinity for x to the power of 5 minus x to the power of 4. Let me write 2 here, and let me write 3 minus 4 x to the power of 5. Can you write down this answer? You can always pause the video, write down the answer, and then I'll provide you with some. And the next example is limit x approaches positive infinity. The question is 3x squared minus 2x over x cubed. The last example here is limit x approaches minus infinity. We have x to the power of 3 minus 4x over. Now this degree is higher. This time I'll make the numerator degree higher, so I'll just write x squared here, right? Now can you tell me the answers for these questions? The first one here is same degrees, ratio of leading coefficients. So it is 2 over minus 4 or minus half. So the first answer is minus half. For the next one, degree of denominator is higher, right? Therefore, this is equals to 0. This is second category. The third category, degree of numerator is higher, and so it does not exist. Do you see that? So once you know this kind of a rule, it is so simple to write down the solution of limits for polynomial functions, as you've seen in this video. I'm Anil Kumar, and I hope that helps. Thank you, and all the best.